Talking about simplifying radicals. Today we're going to be actually adding and subtracting those radicals. Before we do that, they do have a warm-up question for us here. It says to come up with the equation of a line that's perpendicular to the one that they gave us and goes through the coordinate point -2, -5. All right, so we kind of had a warm-up question like this last week. Remember we said anytime we're writing the equation of a line, we want it in that y equals mx plus b form, right? Okay, so what we want to do is plug in everything that we were given and then solve for whatever is left over. So if it goes through this coordinate point, -2, -5, what letter does -2 usually represent in a coordinate point? X, good. And that -5 would represent what letter? Y. All right, so I know I have something I can plug in for X, something I can plug in for Y. They also said it's going to be perpendicular to this one. So we know parallel means they're never going to touch, right? What does perpendicular mean? They cross, right? And exact opposites, right? So if the slope to this one is -2, and this means it needs to be an opposite slope, -2 is the same thing as -2/1, right? The opposite would be to flip it over and change its sign. So if I flip this over, it's going to become +1/2, right? Okay, and is 1/2, or my slope, is that the m or the b in the equation? M. All right, so we got something for m, we got something for x, we got something for y. That just leaves us one variable. So once we substitute all that information in, we can solve for that one leftover variable. All right, so what did we say we would plug in for y? -5 is equal to m. What's our m? 1/2 times what's our x? Good. And then we still have that plus b that we're going to solve for, right? All right, if I'm going to solve for b, the first thing we're going to need to do is combine those terms. And it says we're supposed to multiply them. What is 1/2 times -2? Good. So I'm going to have -5 is equal to, we said that becomes -1 plus b. All right, and what am I going to do now so I can get b by itself? So we want to get the b by itself, so we are going to have to add the -1 to move it to the other side. All right, what is -5 plus 1? -1. All right, so now that I know what b is, we can now write the equation of the line. So the equation of our line, remember, is in that y equals form. We'll have y equals, what did we say the slope was? M is 1/2, x. So what did we say our b is? -4. So this would be the equation of the line perpendicular to that one that goes through the point -2, -5. Okay. All right, so last week or so we spent a lot of time simplifying radicals. That was the numbers that we had underneath our square roots, right? Okay, so today we are going to be adding and subtracting them. But I want you to remember that whenever you're adding and subtracting radicals, we treat them just like we would variables. Like, can you really add an x and a y? No, because they're not the same, right? So that's going to be true with what we're doing today, too. If they're not the same square root, I can't actually add them together. They're different. Okay, it does tell us the 2 steps that we need to follow every single time. Bless you. It says first thing we're going to do is simplify. So that's what we practiced doing all last week. Simplify it as much as you can. Then you'll go in and combine like terms. But like I was just saying here, if you're going to put them together, they have to be the same square root. So must have same number under the square root to be like terms. And if they're not like terms, then we can't put them together. Okay? All right, so on example 1, we have 4 square root of 7 plus 5 square root of 7. Well, can I simplify square root of 7 any more than it already is? No. Okay? Then that means we move on to combining like terms. Are the numbers underneath our square roots the same? Yeah, so we can combine like terms. So this is like 4x plus 5x. What is 4x plus 5x? 9x. So here, 4 square root of 7 plus 5 square root of 7 is 9 square root of 7. You don't touch the square root just like you wouldn't touch an x, right? Okay, let's look at another one. So over here, I've got 8 square root of 11 minus 2 square root of 11. Can I simplify square root of 11? No. But are my numbers underneath the square roots the same? So I can go ahead and actually subtract. Remember, this is like a variable, so like 8x minus 2x. What would that give us? 6x, right? But here, instead of an x, we're going to have a square root of 11. So I'll just have 6 square root of 11. Okay. On number 3, we've got 7 square root of 3 plus 2 square root of 2 minus 3 square root of 2 minus square root of 3. Okay, can you simplify square root of 2 or square root of 3? No. But we can only put together like terms. So which ones would I be able to put together? So I've got a 7 square root of 3 here. Do I have any others that have that same number under their radical? Yeah, at the very end. Okay, there's not a number in front of that square root, so what is it understood to be? What's the secret number there?
1.
Negative 1. All right. So I said I can put these two together. That would be 7 minus 1. What would that give us? 6. 6 what? Square root of 3. Remember, we don't touch the numbers underneath. We treat them like variables. Okay. I also have a 2 square root of 2. Is there anything else like that? All right, so I have 2 square root of 2 minus 3 square root of 2. So what is 2 minus 3? Negative 1. So I'm going to have negative 1, what? Square root of 2. Okay? And I cannot put these two things together because they're like an x and a y, right? They're not like terms. I have to keep them separate. All right, number 4. I've got 3 square root of 6 minus 2 square root of 13 plus 5 square root of 6. Okay? Can I simplify square root of 6 or square root of 13? Which one? Can I simplify square root of 6? No, it would just break into 2 and 3, so no pairs, right? And same for 13, no pairs. Okay, so I can't simplify anything. Do we have any like terms that we can combine here? Which ones?
3, 6, and 5.
Right, 3 square root of 6 and 5 square root of 6. So what do we get when we put those two together? 8. So I'd have 8 square root of 6. Can I put the negative 2 square root of 13 with it? So I just have to tag it on the end. All right. Okay, so those weren't too bad. We just were putting things together that match. Let's look at number 5. All right, so on number 5, we have 5 square root of 192 minus 7 square root of 3. So 192 is pretty big, so we probably can simplify that, right? So let's try and break down that 192. So what's something that multiplies to give us 192? It's even, right? So 2 and something. Okay. 2 and 96. Okay, what about 96? 2 and 48. All right, so we've got our first pair, right? Can I break 48 down into what? What is it? 8 and 6. Okay, that works. All right. Can I break 6 down into what? 3 and 2. Good. And what about 8? 2 and 4. All right, so it looks like we've got another pair there. Can I break 4 down? 2 and 2. All right, so we got a few pairs. What do I do when I have more than one pair? What do we do with them? Multiply them together. So I got 2 times 2, which would be 4, and 4 times 2, which would be 8, and there was already a 5 out there, so that's going to become 40. Good. So I'll have 40, and what was left without a pair? The 3. Yeah, 3 was the only thing. All right, so now I've got 40 square root of 3 minus 7 square root of 3. Now, can we subtract those two? Yeah, because they have the same square root. So what is 40 minus 7? 33. We got 33 square root of 3. All right. All right, on number 6, we have 5 square root of 3 minus 2 square root of 75. Okay, so 75 is pretty big. We should be able to break that down, right? What multiplies to give us 75? Good. And what multiplies to give us 25? 5 and 5. All right, so I have a pair of 5s. So I get to take out a 5. Was there anything already in front? Yeah, that's 2. What is 5 times 2? 10. So this is going to be a minus 10 square root of what was left? 3. And in front, there was that 5 square root of 3. Okay, are those like terms? Yeah. What is 5 minus 10? Negative 5. So we'll have negative 5 square root of 3, right? Okay, let's look at number 7 here. So on number 7, we've got 25 square root of 2 plus 2 square root of 27 minus 3 square root of 98. All right, so we got a couple of pretty big ones there, right, Jack? So what multiplies to give us 27? 3 and 9. And what about 9? 3 and 3. All right, so I have a pair of 3s and 1 left over, right? So I get to take out a 3. Was there anything in front already? So what would that 3 and the 2 from outside give us? 6. And what's left over? The 3. All right, so this became 6 square root of 3. All right, 98 is pretty big too. We can probably simplify that some. It's even, right? Good. 2 and 49. What about 49? 7 and 7. Very good. All right, so I have a pair of 7s. Was there anything already in front? The negative 3. What's negative 3 times 7? Negative 21. And what was left over without a pair? The 2. All right, so now we've got 25 square root of 2 plus 6 square root of 3 minus 21 square root of 2. Are any of those the same? Are any of those like terms? Which ones? Good. Those ones have the same square root underneath them, so we can put those two together. Okay? So what is 25 minus 21? 4. So we're going to have 4 square root of what? Good. And then do we have anything that doesn't have a match? So what are we going to have to stick on the end? 6 square root of 3. All right. Last one. We've got 7 square root of 3 minus 4 square root of 6 plus 2 square root of 48 minus 6 square root of 54. All right, so square root of 3 is pretty small, can't be simplified, right? What about square root of 6? Can that one be simplified? 2 and 3, does that give us any pairs? Okay, so that one's going to stay as it is. 48, that one's pretty big, so we should be able to simplify that, right? 6 and 8, All right, and what about 6? What does it break into? 3 and 2. And 8 would break into, good. So I got a pair of 2's. And what does 4 break into? 2 and 2. So I got another pair of 2's. All right, so what do I do with those 2 pairs? Multiply. What is 2 times 2? 4. And there was already a 2 in front, so 4 times 2, which would be 8. Okay? And what would be left underneath that radical? The 3. Okay? All right, 54 is pretty big too. We should be able to break that one down. What gives us 54? Okay. All right, and what gives us 27? 3 and 9. And what gives us 9? 3 and 3. All right, so I have a pair of 3's. So I get to take out a 3, and what was already on the outside? Negative 6. What's 3 times negative 6? Good. And then what was left and did not have a pair? A 2, what else? And a 3. So I have to put those back together too, right? What is 2 times 3? 6. And that goes underneath. All right. So the first thing we had was a 7 square root of 3. Do we have anything like it? 8. Okay, so what is 7 plus 8? 15. So I'll have 15 square root of 3. Good. All right, the next thing I have is a negative 4 square root of 6. Anything like that? Negative 18 square root of 6. So what is negative 4 minus 18? Negative 22. So I'll have negative 22 square root of 6. Okay, so our rules are, first thing we do is simplify it if we can, like what we learned how to do last week, and then go back and combine anything that matches. All right?